Mount Etna did something in late 2023 that most people missed. It didn't explode. It didn't send a river of lava into a town. It simply changed the sound it was making. For years, the mountain had been relatively quiet, breathing out gas and keeping its vibration low. Then, the sensors buried in the rock began to pick up a new rhythm. The continuous volcanic tremor, the steady hum of the mountain's internal engine, began to climb. It didn't spike for a day and vanish. It rose to 2, sometimes 5 times its normal background level, and it stayed there. If you were standing on the slopes, you wouldn't have felt a thing. The ground wasn't shaking in a way that knocks over coffee cups, but deep underground the plumbing system was waking up. That rising tremor was the sound of fresh magma pushing into the system, pressurizing the deep storage zones and testing the locks on the doors. It was the first sign that Etna was shifting from a passive state to a new, more aggressive gear. And because the signal was invisible to the naked eye, the surface looked calm, while the pressure below was already loading the chamber for what was coming next. This is the trap of familiarity. We look at a volcano like Etna, which erupts often, and assume we know its schedule. We think we'll see smoke before we need to worry. But the data from the last 3 years tells a different story. It shows a mountain that has moved into an open conduit regime, a state where the pipe from the deep earth to the surface is clearer, slicker, and more efficient than it has been in a long time. The tremor was just the first hint. The real proof arrived when the craters we thought were sleeping decided to wake up. By July 2024, the signal turned into action at the Voragine crater. This is a crucial detail because Voragine wasn't supposed to be the main character. For a long time, it was the gas crater, a deep bowl near the summit that mostly just fumed and released pressure quietly. But on July 4th, the behavior flipped. The rim vents started throwing sparks. Within hours, those small bursts turned into towering lava fountains. And it wasn't a one-time accident. It happened again a week later, then again. Between early July and mid-August, Voragine produced 6 separate paroxysms, sudden intense eruptive bursts that act like a pressure valve blowing wide open. The scale of this shift is hard to overstate. A crater that usually just breathed was now throwing ash columns about 9.5 kilometers above sea level. That is high enough to punch through the weather and put rock dust into the cruising altitudes of commercial jets. The ash spread over Catania and nearby towns, coating streets and cars in a gritty gray layer. But the ash on the ground was just the fallout. The real story was the mechanism driving it. The monitoring data showed that these weren't random blasts, they were rhythmic. The episodes arrived roughly every 7 to 10 days. That timing reveals something vital about the machine inside the mountain. It suggests a shallow storage pocket, a small magma tank near the top that wasn't emptying completely. It would fill, pressurize, blow off the top layer, and then immediately start refilling from below. It's like a cistern with a fast tap. As soon as you drain it, it tops up again. The tremor would spike as the flow intensified, the fountains would roar, the pressure would drop, and then the cycle would reset. This efficiency is what makes the current phase of Etna so distinct. Scientific models suggest the mountain is now receiving a continuous supply of magma from the mantle at a rate of about 10.7 million cubic meters per year. Picture a block of molten rock the size of a stadium entering the system every single year. Not all of it erupts. In fact, the data suggests about 70% of it stays underground, cooling into a thick mush that builds the mountain's internal structure. But the 30% that stays fluid has a much easier path to the surface than before. In older cycles, magma often got stuck. It would stall in the middle plumbing, push sideways, and threaten to split the flanks of the mountain. That created a specific kind of danger, low-altitude lava flows that could threaten houses directly. But in this new open conduit phase, the magma is shooting straight for the summit. The vertical path is the path of least resistance. That means fewer flank fractures, but it also means the summit can switch from calm to violent with very little notice. That speed was put to the test on June 2nd, 2025. This event didn't follow the rhythmic script of voragine. It showed us a different, sharper kind of violence, structural failure. On that morning, the southeast crater was already restless. Tremor was rising. The ground was deforming, swelling slightly as pressure pushed against the rock, but the trigger wasn't just the gas, it was the wall. Around 11:20 a.m., the north flank of the crater rim gave way. It collapsed. When a pressurized container loses its lid, the contents don't just leak, they explode. The rapid drop in pressure caused the magma inside to flash boil, the gas expanding instantly. A massive cloud of ash shot up 6.5 kilometers. But gravity took its share too. The collapsing wall and the erupting material formed a pyroclastic flow, a fast-moving avalanche of hot gas, ash, and glowing lava blocks that raced down the Valle del Leone and Valle del Bove. This wasn't a slow creep of lava you could walk away from. This was a high-speed slide of hot rock amplified by the steep slope and the ice on the ground. The mixture of heat and frozen ground made the flow slicker and faster. It followed the valleys like a bobsled run, keeping the danger contained to specific zones, but making those zones instantly lethal to anything inside them. The June 2nd event teaches a hard lesson about vigilance. You can watch the seismometer and see the pressure building, but you can't always predict when a wall of rock will decide it's had enough. The collapse turned a standard pressure buildup into a paroxysm that triggered aviation alerts and sent ash drifting over towns like Brontet and Adrano. It reminded everyone that the shape of the volcano is not permanent. It builds cones just to break them. And just when the system seemed to settle, the mountain reached back into its history. In December 2025, the northeast crater woke up. This vent had been dormant, truly quiet, for about 30 years. A whole generation of locals had grown up thinking of it as a relic. But the plumbing under Etna is connected. When the pressure shifted, the old route opened up again. It started with the familiar signals: tremor, ground deformation, and infrasound spikes on December 24th. The mountain was ruining holiday plans with a clear message of pressurization. By December 27th, the northeast crater was producing sustained lava fountains. These weren't small splashes. They climbed 300 to 500 meters into the winter sky. That is a vertical column of molten rock taller than the Empire State Building. The aviation warning system jumped to red. This is the highest level of alert. It means ash is high, thick, and moving into flight paths. The plume drifted toward the airport in Catania, forcing the air traffic control systems to tighten spacing and prepare for diversions. The fountains were visible on webcams across Sicily, a stark reminder that dormant vents are just waiting for the right conditions. The mountain hadn't forgotten the northeast crater. It just hadn't needed it for 3 decades. Now, with the open conduit system pumping efficiently, it brought the old player back into the game. So how do we watch a mountain that moves this fast? How do we see the danger before the ash is already in the air? The answer lies in the deep signals, the ones that happen 10 kilometers down, long before the magma breaks the surface. This is where the B value becomes the most important number you've never heard of. It sounds like boring math, but it's actually a listening tool. In simple terms, the B value measures the ratio of small earthquakes to large ones. When magma moves through rock, it changes that ratio. If it's fracturing brittle rock, you get lots of tiny snaps. If it's pressurizing a deep chamber, the stress builds up and the system shifts toward larger, tighter cracks. Scientists at INGV, the Italian monitoring agency, tracked this value for 20 years from 2005 to 2024. They found that before the big summit fireworks, the B value in the deep storage zone, way down at 10 to 11 kilometers, would drop. This drop was a signal that the deep tank was pressurizing. It was loading the system. This signal often appeared months before the surface eruption. Think of it like hearing the elevator gears engage in the basement before the doors open on the top floor. By mapping these B value changes, scientists could see the magma recharging the deep roots, then migrating to the intermediate zone at 3 to 7 kilometers, and finally breaching the shallow barriers. The June 2025 eruption had these precursors. The Voragine series had them. The mountain was broadcasting its intent. We just had to learn the language. The tremor signal we saw rising in 2023 acts in a similar way. It bridges the gap between the deep recharge and the surface show. When the tremor center shifts toward the summit, as it did in late 2025, it's a proximity alarm. It tells us the energy is focusing on the exits. When you combine a deep B value drop, loading, with a shallow tremor spike, movement, and rising infrasound, gas release, you get a forecast window. You don't get a specific hour, but you get a probability. You know the system is primed. This multi-layered view explains why the recent activity has been so intense. We aren't just looking at random explosions. We are looking at a system that is being fed regularly from the mantle. The deep B value drops confirm the supply is arriving. The open conduit allows that supply to rise without stalling. The result is a volcano that can fire repeated paroxysms from Voragine, collapse the southeast crater, and reactivate the northeast crater, all within an 18-month window. The danger for the public is assuming that no lava in town means no threat. The June Siseka's pyroclastic flow stayed in the valleys, yes, but the ash from these paroxysms reached high altitudes and drifted over populated areas. Ash is rock. It's abrasive. It destroys engines, scratches corneas, and coats crops. When Etna is in this high-energy mode, the reach of the volcano extends as far as the wind carries the plume. The red aviation code isn't just for pilots. It's a signal that the mountain has engaged its long-range weaponry. Understanding this mechanism changes how you see the news reports. When you hear Etna erupts again, it's easy to tune it out. But if you know the context, that the supply line is open, that the tremor has been screaming for months, and that the internal reservoirs are failing to drain completely, you understand that each eruption is just one pulse in a much longer rhythm. The mountain is building itself. The 70% of magma that stays underground is thickening the pile, creating new obstacles and new pathways for the future. The 30% that erupts is reshaping the summit, filling valleys, and occasionally tearing down the walls it just built. Etna is not a solved problem. It is a living geological engine. The shift to an open conduit regime means we have to be faster. We can't wait for weeks of obvious signs. We have to trust the tremor, the B value, and the subtle swelling of the ground. The mountain whispers before it shouts. In 2023, it started whispering with a hum that wouldn't stop. By 2024 and 2025, that hum had turned into a roar that reopened old craters and shook the aviation network of southern Europe. The lesson isn't that we should be afraid, it's that we should be listening. The ground is telling us exactly what it's doing, from the deep roots 10 kilometers down to the fragile rims of the summit craters. As long as that supply line from the mantle stays active, Etna will keep testing the limits of its own structure, and anyone living in its shadow or flying over its summit needs to respect the fact that the quiet days are just the moments when the mountain is reloading.